Hello, hello. Let me know if you can hear my sound. Okay. Alright, so this is Junichiro Horikawa, and this is the Houdini Algorithmic Live. This is a weekly tutorial live for Houdini that I've been doing. This is the 109th episode. The topic for today is to create one called Auxetic-Like pattern. The reason why I'm saying Auxetic-Like pattern is because the one that I'm going to show you today is kind of a fake Auxetic pattern, because the real Auxetic pattern you see in the example, like if you search on Google Images, the one you see with the Auxetic tiling, Auxetic pattern, is the one that is used for most of the time the digital fabrication, which part of the tile never changes. It's a rigid geometry which doesn't really change, but it deforms with a kind of a hinge on some points to create a pattern, something like these. A deformation like these, and so on. Okay, so as you can see, if you in the real Auxetic pattern doesn't really change its scales for each tile, but the one that I'm showing you today is actually changing its scale like this. So it's not really physically possible to create as a physical object, but I'm just playing fun, doing the virtual geometry, which only possible inside a virtual environment. Okay, so that's a big difference. So that's kind of why I'm writing it as Auxetic-like pattern, a fake Auxetic pattern. Okay, though the idea could be useful for some many like pattern animations or stuff you could do on Houdini using Vex. So anyway, I think I would like to share how I did it. Okay. Okay, so I also did more physically possible pattern using this simple setup using just the squares. In this case, the square doesn't really scale, it preserves its shape by using Vellum as a physical simulator to create a physical hinge simulations like this. Though what I wanted to try out is to create a pattern on top of a given geometry like these. So this is kind of a ongoing practice that I'm doing. Currently it's really not the tile itself, it's changing the shape, so doesn't really make sense as a physical object. But anyway, maybe in the future, if I have a chance, I would like to see how I could implement a paper by Keenan Crane and others, like these one. This is more physically correct by creating a 2D pattern like these, and which could be inflated into a 3D pattern like this, which is pretty interesting to see. So this is more interesting, obviously, but seems a bit hard to implement. So I gotta look into the paper to see how I could do this. But anyway, that's for the future. For now, I'm just gonna show you a simple animating geometry like these. Okay. So let's do this. It's gonna be really simple, I guess. Just let me show you the rules. If you closely look into one of the geometries, like preferably looking into the hexagon, like something like that. And also I'm also deforming the surface itself together with the Auxetic modifications or deformation animation. So if I remove that deformation on a surface, it will look like this. Okay, so each triangle rotates with about 60 degrees in each direction, and the one that's connected to the triangle, which is this one, rotates in the other direction, and keep that rule the same for all the other triangles, which is next to each other. Okay, that's the main rule here. Simple as that. But sometimes there are polygon like heptagon, octagon, or pentagon, which doesn't really make sense to create a continuous rotation like these. If the number of edge of the polygon is odd number, you have a space like these, obviously. So which is a bit hard to like solve, so I just leave it as it is. So this doesn't really connect to any of the edges, any of the corners. So also physically it's a bit hard to create. But anyway, if you look from far away, you don't really notice that much. So I guess in some case it might be okay visually. Okay, so that's what I'm gonna try to do today. Let me know if you can hear my voice. Hopefully this is on live. If not, I'll try to make it fix. Okay. Hopefully the sound is okay. I'm gonna just start creating the function or sketch. All right, so let's do this. First thing first, I am going to start by creating a geometry node as always. Let me save it into the folder. All right. So let's start by creating an input geometry, which could be any kind of geometry. So I'm gonna try to make it simple by starting with a sphere, which has a polygon option, which already have a nicely triangulated shape. So let's also increase the number of triangles by increasing this frequency a little bit. All right. The good thing about this sphere is that it has a small number of singularities, meaning small number of polygons, which is other than hexagon. So in this case you have pentagon at some points, maybe at the corner, but other than that most of the neighbor polygons create hexagon for each point. Okay. Which is nice one to try out with. So let's go with this first. They'll go back to other geometries which could have more singularities. Okay, so first thing first, what I am going to do is to create some kind of a rule in order to determine which triangle rotates in which direction. Okay, for example, if I choose this triangle to rotate on the clockwise direction, then the one that's next to this triangle should rotate in the other direction. Okay, So let's say if I choose this one to be the clockwise rotation, then I want these neighbor triangles to rotate on counterclockwise. Then these one, which is neighbor to this one, should rotate on clockwise, and so on. So I want to make a rule in order to find out which triangle rotates on which direction and which orientation. Now it's a bit hard to find out with these three-dimensional shape. If it's 2D, then there is some way to do this, but if it's on 3D, it might be hard to geometrically determine which one rotates in which direction. So what I'm going to do is to recursively determine the orientation for the rotation. So meaning once I chose the first triangle to rotate on clockwise, then I'm going to look into the neighbors. Then let's say these neighbor triangles should rotate on a counterclockwise. Then again, in the next iteration, I'm going to look into the next neighbor triangles, and the next neighbor triangle should rotate on clockwise, and keep doing the same duration over and over again recursively until we fill the whole triangles with either clockwise or counterclockwise. Okay, so at some point you're going to fill those pentagon or heptagon or any other triangles which is inside the other than hexagon. So in those cases, if this one goes clockwise, if this goes counterclockwise, clockwise, counterclockwise, clockwise, then these two neighboring triangles might share the same orientation. In those cases, I'm just gonna keep it as it is, make it both rotates on clockwise. Okay, so that's what I'm going to try to create. Okay, so in order to do this, I'm going to start by creating or setting a single triangle set as a rotation, as a clockwise rotation or counterclockwise rotation. Maybe I can just get random triangles out of these sphere and just set some group in order to determine that it is rotating on clockwise first. So I'm going to create an attribute wrangle. I'm not really sure if the sound is on. Hopefully it is. I don't know. I can't really tell from the the internet web page. So let me know if you cannot hear, or let me just write it on the chat. Right, let's continue. So I'm just going to use a detail wrangle to select random faces out of this polygon. In order to do that, I'm just going to say index is using a random number with some seed value, which will give you a value in between 0 to 1 and a float. I'm going to multiply this by a total number of faces, which is n primitives 0. Now I will make it as an integer because I want to use it as an index. Like that. Okay. Now hopefully this will give you a random number for this one, which will be in between 0 to a total number of this faces, which indicates these numbers. Okay, so, and what I'm gonna do is to set a group to this number face. Let's say I'm going to name it as check, or maybe other group might be better. Let me see. Since there is one that rotates on clockwise and one that's rotated on counterclockwise, I'm gonna make this as CW for clockwise rotation. And I'm gonna convert this index into a group. Wait. Wait. Set prim group. Yeah, I can just say index. Then 1. Okay. So start group. So let's check which one became the first face to rotate clockwise. I'm gonna make this primitive color, make it red, and only put the color on the clockwise group. Okay, so where the okay, here we go. So this one, the one that I have drawn in red, is going to rotate clockwise. If I change the seed, it should change the position. Okay, like that. Alright. Now it's time to recursively expand this information to whole faces, so that whole faces can fill up with either clockwise or counterclockwise information. So the next thing I would like to do for here is to check the neighbor polygons out of this counterclockwise group. Then the neighbors is going to be set as counterclockwise group. Okay, so that's what I'm gonna do today. What I'm gonna do next. I'm gonna use a primitive wrangle to get all the CW groups, clockwise group, by setting a CW filter on a group. Then let's name this CW neighbor to CCW. Okay, so what I'm gonna do here is pretty easy. I'm just going to get all the neighbor polygons out of which belongs to this one, which connects to this group, by using poly neighbors, which in this case should give you 3 polygons because there's only one CW group. Okay, now I'm gonna loop through all the polygons and check if these doesn't have any group set yet, either CW or CCW. Okay, so if imprim group CW for polygon, the neighbor polygon, is equal to 0 and imprim group 0 CCW polys I is equal to 0, then that means these faces are still empty, meaning these are still white. So I can set a either CW or CCW for these. Now I'm looking at the CW right now, so the neighbor should be CCW. So I'm gonna set prim group like that. Okay, let's check by coloring these group with maybe blue. to CCW, and there you go. You have now 3 triangles, which is a neighbor to the CW polygon. Okay, and after that I'm going to do the same things but from CCW to CW. So I'm just going to copy this set and just replace some of the letters, like change the CW to CCW. Now you're looking into the blue ones, CCW, then check the neighbors which belongs to this blue one, which is empty. So the condition is still the same, you just need to change here. Okay, then for the color I'm going to set this as red for CW. Okay, and do I see any changes? No. Let me try to reset this, and okay, here we go. So that's for one loop. Okay, this is an initialization setting the very first faces, and this is the one that is going to define the neighbor groups. And what you're gonna do next is to just keep doing the same process over and over again until you fill the whole faces with these either CW or CCW. Okay, so that's what I'm gonna do. So, but you don't really know how many iterations you need in order to fill in the whole space, so probably I'm going to use a for each number loop with the feedback loop option, then decide when to stop decide to stop the loop when it has no empty spaces anymore. So I'm gonna change this to feedback each iterations, feedback fetch feedback, and just move this process inside here and keep doing over and over again like this. Okay, and looks like it's working pretty good. Just by using 10 iterations, it's already running the half of the sphere like that. And if you increase more at this point, probably it will take around 20 to 22 to fill in the whole space. Now you can see that you do have some triangles which share the same color. That is because of these pentagon that I have told you, which creates the singularities cone. So these places might have some problem in terms of the animation, but overall it looks pretty okay. Like these one, other than that, looks pretty much okay. So let's just go with these. We could maybe think about these conditions later in terms of the animation, but for now, let's just keep it as it is. All right. Now the things that I want to do is, since we don't know how many iterations we need to give, I'm gonna try to give a really high number as a number of iterations, but stop the loop as soon as it fills all the polygons. Okay, so in order to do that, I'm going to use this, have to use this stop conditions to make it once in order to stop. Okay. So somehow I need to create some conditions out of these. So in order to do that, let's create like an attribute wrangle, additional attribute wrangle to create the stop conditions. Now the rule here could be the number of red and number of blue, the total number of red and blue. If the total number of red and blue is equal to the total number of faces, that means all the faces has been reserved by these rotated triangles. So that's when you want to stop. So let's change this to detail, and I'm gonna count all the blue and red faces by using expand prim group functions, which gathers all the primitive numbers which has specific group name. In this case, CW. And if it's CCWs, just do the same thing like that. And if the total length of CW plus total length of CCWS is equal to total number of primitives, that's when you want to stop. So I'm going to create a attribute for detail called stop to 1. Okay, so what I'm gonna do now is to check the stop conditions which is inside here, and as soon as it gets to 1, the loop should stop. So the attribute name is stop. All right. Okay, seems like it's missing one loop, so maybe I might need to place this on here. The first it's going to be the first process to check whether it should stop, so that you can have additional loop. Alright, so looking at this, looks fine. The maximum number of iterations currently is set to 100, but it stopped when the iteration comes to 21. And it doesn't really change if you even increase it to 1000, still stops at 21. Now that's good. Okay, now that looks good. Now it's time to make each of the triangles, red one to clockwise and blue one to counterclockwise, to create more like an Auxetic tile-like deforming animation. Again, as I told you, this is going to be a fake Auxetic pattern, but animation-wise looks similar. All right, so let's do this. I'm gonna make it as really simple in order to make this rotate and doesn't really expand its the Auxetic means to kind of to expand, right, to inflate or something like that. But because I want to keep the original mesh geometry, original mesh proportion to be the same, even if I rotate to expand the geometry, to expand the tiling, I'm just going to make the tiling itself becomes smaller. Each triangle becomes smaller when it rotates, and make it back to the original shape when it rotates like 60 degrees. So what I'm gonna do is to pick one of the triangles and rotate like that. But just by sliding each of those points to which runs on top of this edge. Okay, so I'm going to move this point of this triangle to this direction along this edge, and this point along this edge, and this point along with this edge, from this point to this point. Okay, now the one that's drawn on blue, I'm going to pick the edge direction to the reverse direction. If if I set the orientation of the edge of this red one to go clockwise like this, then for the blue one I'm gonna go counterclockwise. So the point will go from this edge, this point to this point, slide from this point to this point, just like this point to this point for this triangle. As a result, the point at here will be connected for both blue one and red one. And if you do the same rule for all the other points, for all the other blue and red one, you'll eventually have a connected piece for all the triangles if it's hexagon. When it becomes pentagon or heptagon, which creates the neighbors like these, you're going to start having a gap between the points. But otherwise, if you have red and blue like a checker mark, you'll be able to have a connected triangle pieces, even if you rotate it, or even if you make it look like it's rotating. Okay, well, I'm just gonna show you how you can slide one of the triangle points to this direction, okay, as an example. Okay, in order to do that, I am going to use a let's say primitive wrangle again. Alright, gonna just test it by picking one of the primitive and see how it works. So I'm going to show up the number of primitives to pick just one triangle, something like this one, 446. So let's say I'm gonna only modify the 446 number triangle, okay, in order to rotate and show you what I mean by sliding the points on these edges. Okay, so first thing first, what I'm going to do is from this primitive, I'm going to get the half edge informations. Half edge is the edge information belongs to a primitive which has an order, which has the direction. And I'm going to use that information in order to determine in which direction should the point slide. Okay, so first thing first, I'm going to get the first half edge information from the primitive using prim edge, which will randomly picked. I mean, it's not really random, but we don't really know which edge is going to be picked for the first half edge using this function prim edge. So given that as a base starting point, I'm going to loop 3 times because we have 3 edges for every triangles. And for each iterations on this loop, I'm going to try to determine the point position for this triangle, meaning I'm going to recreate the triangles which fits inside these triangles. I'm going to create an inner triangle inside this base red triangle. Okay, just by getting the ratio of the edge from starting point to the end point, starting point to the end point, starting point to the end point. If it's 25% for each edge, which will be this point, this point, and this point, will give you a triangle like these. If it's half, 50%, then you'll have a triangle like these, and so on. So in the loop, I'm iteratively going to create the half edge information or update the half edge informations using edge next, which will give you the next connected edge for this primitive. So if you do this 3 times, you're going to loop through all the edges for this triangle. So first do like this, and then I'm I'm going to get the starting point and the end point of this half edge in this loop. Starting point can be get retrieved using edge source point. And then you also want to have a end point which is edge destination point. All right. Now, in order to determine the actual positions from starting point to the end point, you do need to have a real position information as a vector. So let's also retrieve the vector value p attribute from this point number. Now you can determine the positions which is in between S position to E position with a specific ratio. So let's try to create some ratio value. I'm gonna just name this as T, which is going to be in between 0 to 1. And use this T value to lerp between the starting position to the end position for each edges. So the new position will be lerp S position, E position, and T. Now this will be the new position which will be inside, which will be on top of this red triangle. So let's check this out by creating it as a new point. Or maybe I can just modify the point position of this triangle by making it making all the triangles as a separated primitive, meaning all the points is unfused. I'm gonna use the unique points to unfuse all the points so that each one is being splitted. I can now rotate each triangle separately. Fire like that. Okay, no longer the point is being connected, so it's not going to influence any neighbor triangles anymore. All right. So now that I get the new position, I'm going to replace the current point position with this new position. Now currently I don't really have a current new position here, but maybe I can just use this SPT as a starting point position which I want to modify. So let's say I'm going to modify the attribute of this SPT. I'm going to modify the P attribute of this SPT with a new position and see what happens. Okay, now if I move this slider from 0 to 1, you can see that the triangle is rotating or sliding. Each of the points is sliding on top of the edge like this. The size is being resized to something smaller than the original triangles, but it's being rotated like that. Okay, so that's good. That's good for the red one. From 0 to 1, you see that the triangle is rotated clockwise like that. Okay. Now what I want to do next is to do the opposite things for the blue one. Rotate on opposite direction. So if the group is within CCW, then rotates in other direction. So the next one, the neighbor primitive is 474. So I'm going to name 474 as well. Do this filter, check this out. Now currently everything, the two of them are rotating in the same orientation, so as you can see the point is not really connected to each other. It's just rotating individually the same direction. But the one that I would like to do is to rotate this blue one to the opposite direction. So I gotta have to create some conditions for that. So in order to do that, I need to check whether the primitive is inside a CW or CCW. Okay. So let's create the CW variable to check if the primitive triangle is inside the CW group. In prim group CW. Okay. If it's red, meaning if the CW is equal to 1, then you want to rotate on the clockwise direction, which is this value is correct. If otherwise, if it's blue, then you want to rotate on the other direction. So I am going to modify this t value. If the t goes from 1 to 0, then that means you're going to rotate on counterclockwise. So if CW is equal to 0, meaning if it's equal to blue, or CCW equal to 1, then modify the t to 1 minus t, which will convert the t value from 1 to 0 if the t goes from 0 to 1 previously. Okay. Now let's see what happens. Okay, something weird is happening with the blue one. I think something is wrong, obviously. Interesting. What's happening here? I realize I have to put it outside the loop, because since if it's inside a loop, the t is iteratively updating over and over again. That's not what we want. We just want to update the t value once. So don't do that on loop. Just do it outside the loop. And let's see what happens. Now looks go nice. As you can see now, each of the triangles rotated on the opposite direction. And because the ratio is the same for every triangle, you are getting, and the edge length is all the same for neighbors, you always have some connection with other neighbor triangles if the color is opposite. Nice. So looks good. So I can just get rid of this filter to apply this function for every triangles on a geometry to see what happens. There you go. Working just fine. Now if we look at the one that has the same color two next to each other, let's see what happens. Now this one has a bit of problem because it's not really connected, because it's rotating in the same direction. So it does have some problem here. But overall you do have some connections at somewhere. So I might be okay with these. Some might not be okay with these. It's really up to you. But yeah, well, if you want to try to fix this, it's gonna be a bit hard to figure out. You might need to create some conditions if the neighbor is both blue, or if neighbor is both red. You do need to give some kind of other kind of transformation other than rotation. So for now, I don't really see what could be the best rule for that, because as you can see, it does connect when its t is equal to 0.5, but other than that, it doesn't really connect to each other. So it's a bit hard to determine. This one rotates fine. which has the connection. Only this point is not really connecting, but you can't really tell that this will always not be connecting, because if when it becomes more complex, you'll see a lot of separation like these. So it's a bit hard to give uniform rules for this kind of situations. Let me know if you have any ideas for this. I would like to hear. But for now, I'll just ignore this for now. And if I could come up with some idea during this live, I'll try to implement this. Now, overall, it looks fine. Now the next thing I could do, maybe, I mean, in terms of the visualization, this is still okay, but maybe it's not that interesting in terms of the animation. If I create a expression like sine wave to fit f start from f end from 0 to 360 degrees with the sine, then we map it into 0 to 1. We'll create a looping animation like these. Or you could probably also go only to the clockwise direction by, let's say, remove the sine, just give a simple remap like this. And this will give you a kind of a continuous rotation, which could also be interesting. Right? But maybe using sine looks more physical. I mean, it's not really physically correct, but looks more interesting, so I'm gonna go with this way. Now, one thing I could make it a bit more interesting is to modify the surface itself. Right now it's a bit uniformed shape. All the triangle shape is pretty much the same for this sphere. So why not give some deformation to this surface itself? For example, using some kind of noise or something. For example, if you just move the surface using noise, you could probably create a direction using noise function with P and subtract by 0.5 for each x, y, and z coordinate. Then move the point with this direction by some scale. Right? And in order to make it as animation, it might make more sense to add a frame-based value. Like that. So even though the shape is being deformed like these are still triangles. So you could still use the same functions to give a rotation, because it's just sliding on the edge, doesn't really rotate, it's deforming, so it still works. Okay. So that's the good part about this one. Right. Let me try to visualize this to become a bit more interesting using maybe matcap shading. Right. Give some textures to the matcap. Maybe I could use a gold-like material. One thing I noticed when I use matcap shader or matcap material inside Houdini Preview, it's always seems it's better to make the gamma equals to 1 to make it linear, to have the right color. Okay, this looks more like a gold. Right? Interesting. And maybe I could use a polywire, poly extrude to give some thickness to each of the triangles. Bit too thick. That becomes a bit more interesting. Now, I was practicing using a new node from Houdini 19.5, which is this tangent field, and I was wondering if I could use this for animation, and I thought maybe I could use this to modify the shape, the surface, without changing its silhouette of the base shape that much, but just remove the edge informations on the surface. Meaning just slide some of the points which is on top of the surface using this tangent field. Okay, let's give this a original look. If I use this tangent field, it gives you a vector field on top of the given surface, like that. And I thought if I just move the point, each point within using these direction as a guide, maybe I could just, I don't really need to, I mean I can just slide the points on top of the surface using these. I mean you could probably do the same things using UVs, but maybe this could be another way to do. So let's try it. Right, so if the default parameter for this tangent field gives you 4 direction for each point, which is called field 0 to field 3. Now field 0 is one side, field 1 is another side, field 2 opposite side of the field 0, and field 3 is the opposite side of field 1. So probably I could just get field 0 and field 1 and use those two perpendicular directions to define a custom directions on top of the surface. Right? So gonna use the point wrangle. I'm gonna name this deformed surface, and first thing first, I'm gonna get two field 1, which is named as field 0, field 2, which is named as field 1. Okay. And just by combining these two vectors, you'll be able to create any directional vector values which is along this sphere. So what I just need is a combinations of this one and this one, meaning I need two random values in order to combine these, which is in between -1 to 1 for each of them. Then you'll be able to get any directions on the surface, top of the surface. So I'm gonna create a random vector2 value for each point, or maybe might not be better using random, but instead I'm just going to use noise, because each connected triangle might be better to have a similar direction. Say so, just as I did for this one, I'm going to use the noise, and probably I could also add a frame value for this one, and I'm going to subtract this by 0.5 and 0.5 for this one as well, so that you'll be able to have a value in between minus 0.5 to positive 0.5. Just in case, I'm going to multiply by 2 in the end, so that the value is in between -1 to +1, which is not really important, but let's just do this. Now that I have two value x and y for this random, I can use those to combine these two vectors to create a random vectors, random directions, which is on top of this sphere, which is always a tangent vector. So tangent vector, the final tangent vector is f1 multiplied by random.x plus f2 multiplied by random.y. And finally, maybe I can just normalize it, or maybe not. I'll just keep it as it is. And then finally, I'm going to multiply this by some moving distance, the maximum moving distance. Then move the point with this tangent direction. Okay, now let's see what happens. Okay, if I play this, you can see that it is keeping the sphere shape as it is, but the point is sliding on top of the sphere. Now some points are moving to the really different direction. Maybe it's due to how it creates tangent vector, this one, especially when you have singularity points like these, the tangent vector becomes something different. So in those cases, maybe I could blur the tangent vectors a little bit using attribute blur to smoothen out the neighbor tangent vector values a little bit for field 0 and field 1, just to make sure that you have enough smoothness in between the neighbor tangent. Now still have some strong gaps here. Maybe I could also increase the seed. Getting interesting, but as you can see, the overall shape is pretty much being preserved. Maybe if you want to preserve the geometry as much as possible, you could also use the ray node to the original piece to keep it sphere as possible. Now let me, okay, I have to make this field 1. Okay. Now it looks more nicer. Now probably I could increase the D value a little bit more. like that. Interesting. If I make it too much, maybe I might have going to have some problem with more complex geometry, so let's keep it at small. And now if I replace this to use it for Auxetic animation, let's see what happens. Looks like these. Interesting. Now if I make this shaded back to a gold, okay, wait, where does the gold go? Somehow it's been reset. I don't know why. Right. So looks a bit more interesting. Yes. All right. Cool. Let's try this with other kind of geometries, such as pig head, and see if this could still work. Now it is doing something, but it looks funny because this is not triangle. Yeah, so I think I need to convert this into triangle. I mean, there are Auxetic tiling which also supports squares, but the rules that I wrote here is only for the triangles, so I need to make this as a triangle. So probably I could use remesh. More like it. Nice. Alright. Now I do see some jump from the end of the frame to the first frame. It's not really looping, so let's make this looped for this deformation for the surface. I'm just using this frame as it is, but I guess I need to do something in order to make it as a loop animation. Now probably I could use P noise for that. Periodic noise. Now I forgot what the parameter is. I guess you cannot create a vector 2 output, you only can create 3D output, but that's fine. You can just get x1, x and y. That's all. So P noise, and the input is, the input that I need is the seed and the periodic number on x and y and z. Right. Now which one can I use? Probably this one, I guess. The fifth one, XYZ as a seed, and PXPY and PZ for a periodic number. Alright, so okay. First of all, the point position, I can just use the same point position for this one. And for the animation part, the frame part, I could probably make this as a vector value. So first give it as a variable, and make it as vector value. That. And gonna have to define the range for the periodic range. The more number you have, more variations you get, I think. Let's try with 4 for every x, y, and z. And in order to use that, I need to make this range in between 0 to 4, I think. So I'm gonna use a fit function to fit the frame, which is in between f start to f end, and give it 0 to 4. Okay, maybe I should make it as a parameter, I mean variable. So replace this with frame. Actually, this has to be an integer, so make it as an integer value, like that. Okay, that should do it. And just as I did last time, I'm going to subtract this by 0.5 for each x, y, and z, and see what happens. Okay, it's not really moving at all. Maybe I have some problem here. The surface itself is not really moving, meaning maybe this one is not really working properly. Probably. Let's see. Let's check if the surface is moving. Nope. I'm gonna have to check if this one is really changing its value. Let's go to the point. Okay, so obviously f is not really changing, so maybe it's due to use wait, I didn't set the frame value. All right, okay, now looks good, and it is repeating as I assumed. If you have less number, you have less variations. All right, looks good. So it should do the job. Now you are able to create a loopable looping animation, both with deformed surface and a Auxetic-Like animation. All right, if I can increase the more deformations, still works. Nice. Okay. So far so good. Where was I? So probably I am pretty much okay with these results. I think I'm pretty much done. Only thing I could try out more is how I could deal with, what's this? How I could deal with the neighboring triangles which shares the same orientation, same rotation. In this case, these one. I'm seeing a funny color here. Maybe it's due to the attributes or the material. We just delete the material informations from this pig head. Hide the UV. All right. So I don't know if I can do anything for this one. Let's see. Well, if you don't rotate this, that might not be really interesting. And as you can see, this one has really long connections like these. Let's see what's happening here in terms of the animation. So these are all separated, splitted, no connections to each other for these red ones. Well, yeah. But if there is a way to create new triangles out of these, let's see. For example, for this one, no, I don't think it works. Pretty hard. Pretty hard. I don't know if there is a way to fix this thing. What I just need is inner red triangles in here, but all connected to those blue, not to the red. No, that's a hard thing to do. Maybe I could keep it as square. If it's connected as same color, just have a single square and just, I don't know, slide the square edge. That might work. That might work. Okay. That might be interesting. I'm gonna try. So if it's square, then I might just want to slide for each point to those edge. Okay. And that, in order to do that, I cannot fix the number of the edge to 3 like I did here, but it should be related to the number of edges for each primitive. So, well, I can just say lengths of prim points, like that. Number of points mean number of edges, so this should do the job. Okay, for now I'm going to ignore the deformations because it's a bit hard to see, so okay, I still see the deformations. Or is it not? Okay, so this still works. Now what I want to do now is to make this connected triangles which shares the same color to be one big primitive. Yeah. In order to do that, I need to dissolve this edge, inner edge for this triangle, procedurally somehow. I could use the node called dissolve if I want to do it manually, which will, where did it go? Which will dissolve the edge, creates the quad face. Now let's see what happens with the animation setup I created. Where did it go? Why do I have another edge being created? Maybe I need to reset it. Okay, now if I play it, okay, seemed to work pretty good. So now all the edges points being connected, even though if I have any other primitives like other than hexagon. So this is a good idea. This could be a really good idea. So if the primitive is being connected with the same color, I can just dissolve those inner edges, and that might just fix like this. Alright, so let's think about how I can do this procedurally, shall we? So we have so many conditions like that for this pig head, like this one. This is even connected 3 pieces, so it's a good example. So let's see how I could do this. What's the best way? So obviously I have to do this after this node, after I have created all the variations using this loop, and after that I'm gonna think about how I can make this. Well, maybe I can split it into a clockwise triangles and counterclockwise triangle and deal with each of them separately. Might be easier. So first get only the red one. Now it looks much easier to deal with. Maybe I can just use a divide node and use remove shared edges. That's it. Seem to solve. Wow, that's a really big polygon. It might look really weird when it's animated, but let's see. Do the same for the blue one, like that, and merge these back together. Okay, it looks a bit weird here. But let's see. Then connect this back to this one. I don't think I need to fuse this one because I'm still creating every point's unique on the ladder process, this one, so I think this is just fine. Let's see what happens with the animation. And nope, something is wrong. Everything is rotating in the same direction somehow. Weird. Maybe I'm missing a group informations for each primitive somehow. Yeah. After I did the divide node, seems like the group has been destroyed. So maybe I have to reset the group. Okay, no problem. This one CW, this one CCW. Now every polygon is being connected. Now obviously this is no longer a rotation, it's more of a deformation, but every point is being connected. Well, this one's rotating in some funny way, but overall rotating in a fine manner. Everything is being connected, even though you have a irregular piece like these. It's rotating as a square, so looks pretty nice. And make this back to matte cap shader. Why am I losing the material informations all the time? How's this? There you go. Nice. So you no longer have any gaps between polygons for any kind of shape, which is, I think it's pretty nice. You know, this connection is a bit funny though, but overall looks fine. Yeah, I think I like it. And let's try to make this a bit more smaller. Yep. And if I switch back to a bit more simpler geometries. Nice. So when the neighboring triangles share the same color, it rotates as square, like these. Good. Yeah, I think I actually like it. I'll try with the other kind of geometry, and if I don't get any questions in a comment, then I'll just finish this live. Shall we? I don't think I'm getting any chat, right? Because I don't see anything. Maybe I'm still not sure if the sound is on, but hopefully everybody is able to hear what I'm saying. If I change this to a torus. So I made a choice. I made a update to the rotation so that any number of primitive could be used, so it's even working with squares. Nice. This looks really interesting. Nice. I think I like it. Then I might not need to remesh the pig head after all. Let's see what happens. Oh, this is going funny. But looks interesting. This has a really long polygon, which looks really funny. But overall, it's looks fine. Maybe I might need to tweak the rules, how the neighbor should be set. But overall, looks pretty much fine. Let me see how it looks like with the red and blue for this big head. I see. Looks a bit too long. If I can make this red, I want to make this blue. I want to make this red, I want to make this blue. Yeah, so since I'm doing a bit brute force way to set the red and blue colors, I do seem to have this kind of issues. Go from 0 to 1. Although, in order to fix that, that's a bit too much. So, till here looks fine. I do see some problem here. When I do this, yeah, I have some problem like these. Getting more continuous strip like these. I see. Now it looks a bit hard to solve this kind of problem if you do it recursively. Yeah, I cannot really think of a good way to solve this instantly. If I just look one by one without using like multi-threaded or wrangle, maybe I can do it, but it's gonna be much slower, so I don't want to do that. But if you just look into faces one by one, maybe you can have more optimized neighboring informations for sure, which is somewhere around here. Instead of using primitive, maybe you can use detail and get all the neighbor polygons which is neighbor to the red or blue. Then one by one try to figure out whether it should be blue or red next, considering the previous changes as well. Although that's too much to do, so I'm just gonna go with these. Let's say I am fine with this. Okay. But the torus one looks pretty nice. Yeah. This one's working pretty nice. All right. And what else I could try? Is there any other primitive that I might be interesting to try out? I don't know. Maybe rubber toy as well, just to make sure that this works. Oh, I think I do have one problem with this setup, especially with this kind of rubber toy. If I change this to rubber toy, where did it go? Huh. Yeah, just as I assumed. It's just getting the part of the geometry. That is because this only works on one connected piece. So this rubber toy has separate connected pieces. So in order to deal with this kind of shape, I need to make this possible. They make this setup possible, process possible for any connected piece, any number of connected piece. So I think I need to do the same process, this one for each connected piece. Choose the start group, then do the process over and over again. So I think I can just use a for each connected piece for that. Then just move these inside here. Alright. Let's organize this a little bit. Then now everything is being checker marked, checker tile. Wow. Then I can connect this to here, right? It's taking a little bit of time. Hopefully this works. Oop. What happened? Let's see. Visualize this. Maybe I need to normalize. Looks a bit dark. Let me change this to a madcap shaded. Oop. Okay, I think it's working. Now there are a bit too much polygons, but it's still, I think it's working just fine. Yup. Slow as hell. Now this is good. Cool. All right. Nice animation here. A bit interesting, bit funny animation here. Why am I having this kind of shape? I see. Okay, I guess that makes sense. If I have a connected squares, I am going to have animation like that. Like that. Okay, well, that's that. But still, everything is connected, so I guess I'm fine with it. Cool. All right. Okay, I'm still wondering why am I not getting the chat. Wait a minute. Okay, I know. I realized that I have set the chat to top chat, which only shows some messages such as potential spam may not be visible. So I have just changed the chat type to live chat, and now I see many comments here. Sorry, I didn't realize that. Okay, I did realize I do have a lot of comments. Thank you very much. And Tito Morales gave a super chat as well. Thank you. Thank you very much. Sorry, I didn't really follow the chat. Okay. Thanks for all the comments. Thanks for all the feedbacks. Thanks. Thanks. Okay, well, so I think I am pretty much done for today. Pretty much satisfied from what I have done for today, especially in order to connect all those separated points, which I couldn't solve it before starting this live. So yeah, pretty much satisfied with it, and works for any kind of polygons, which is also pretty nice, I think. I don't know what to use this animation for, but just for fun. Would it be, I got a comment from Eric. Would it be possible to have the spinning animate in amplitude across the surface? Spinning animate in amplitude across the surface, so that the spinning travel. I see. Yeah, that's totally possible. I think should be. All right. Yeah, think so. Shall we try that? Okay. Let me organize this a little bit before we get it into that. In terms of organize, I mean just pack with this network box, just, and rename the wrangle to some easy to understand stuff. Okay, so let's try that. So what I just need to do is to modify this, control this t value based on the point position on the surface. So first let's create some points which run top of the surface, Maybe for that reason I could probably use this tangent field or maybe a random noise field to travel through the surface. Could be maybe that could come from the solver to make it a bit more interesting. I don't know. Maybe give a solver. And since tangent field is a bit too slow, I'm just going to use a noise field, maybe curl noise, something on top of the surface. Right, so first I'm going to create the noise field on top of the surface. Let's just get this back to a red and blue. And noise field. Okay. So I have, maybe I could use this curl noise 2D and combine with the tangent field. And if I don't animate the tangent field itself, that might not kill the process, so that might be okay. So just like I do for every other noise, I create the noise field. And maybe I could use similar parameters that I created right here. Maybe I can just copy this. And connect this to here. Is it possible to make the similar effect on GPU? Yes, definitely possible, yeah, I believe. If you use a vertex shader, I think. I feel that shader is more suitable for this kind of fetch preparation. Yeah, I think so. The Vex itself is coming from the shader language, so it's pretty possible to transfer this into a shader, I believe. Especially if you are modifying the geometry itself, using vertex shader makes sense, I think. Okay, where was I? So I wanted to use the curl noise instead of the P noise. Right, which will give you a vector 2. So maybe I don't really need to do this. And now let's see what happens. Oops. Cool noise. Okay, I don't really need these, so I don't really need these. Well, I think I. Okay, no matching function for vector 2 cool noise 2D candidates are vector cool. Okay. Seems like I have to make it as a vector after all. So let's go with this. Now, which should only give you X and Y value, I think. And let's see. Now what I want to do is to create the vector field with this newly created tangent vector value Let's see how it looks like. No, the name is field. Okay, am I not seeing anything? Do I get any value? Nope. Nope. Okay, where's that? Okay, I don't think let me see. I gotta check one by one if I'm getting this value right. Okay, yeah, I do get the coil noise. Maybe I am not getting the tangent field. Okay, that's the reason. Maybe I can just come from here. All right. There you go. And if I play it, okay, it's a bit too long. The line is too long to check. Let me make this smaller. Okay, so seems like a nice tangent, I mean nice field. Maybe it's a bit too fast. Yeah, something like this. Okay. This doesn't really give anything, so let's go to frame to all right. Hey, thank you, Eric, for the super chat. Appreciate it. Right, so now that I have a field, let's try to move some points along with this field. I'm just gonna create a bunch of random points on top. Oh, Willis VFX, thank you. Thank you for the super chat. Thank you very much. And let's create number of random points, maybe like 5 points or any number of points, and try to move this point along with this coil noise field using solver. I mean, it doesn't have to be a solver, but might make sense to use a solver. And yeah, let's see. So this is a geometry, this is a point, which I'm going to make it pretty easy. I'm going to sample the moving vector from this second input, which has the coil noise field. I'm going to use the UV sample and get the field value using point as a sampling position, using current point position. Now I'll be able to get the field from the second input. I just need to use this to move the point to that direction with some distance or speed. And I also want to make sure that the point stays on top of the surface, so I'm going to use the ray node. So that the point will always stay on top of the surface with the minimum distance. Alright, let's see. Nope, point is not moving, which is because maybe I'm not getting the sample correctly. Let's see. Am I getting the field value? I don't really have the field. Why is that? I did name it field. Should come from the second input. Wait a minute. Yeah, I don't really see it. Why is that? Do I see it here? Yeah, I do see it here. It's moving. Yep. Will I go inside? Oh yeah, actually I do. I do have those values. Okay. It's good. So I should be able to sample these value, which is named as field, I think. Right. Okay. And sampling with the point. Yeah. It's not really changing. Let's see what's happening here. Okay, I am getting the value here. I realized I didn't set the value for speed. Currently it's equal to 0. That's the reason. Of course. Of course. Alright. Now the point should move along with the vector field. Looks too fast. Let's modify the speed. Still. Okay, well, good enough. So these points is going to be the attractor to define the spinning ratio for this thing. Okay, so I'm gonna make a variation. This is a uniform spinning, which I'm gonna keep it as it is, and I'm gonna create a variation for this of this one, which is going to be based on points, attractor points. Okay, and this one is going to refer to the attractor points on the second input to define the rotation angle, which in this case, this t value here. So I am going to remove this expression here, keep it as 0 for now. Maybe I'm not going to use the parameter after all, so remove this parameter. But instead I'm going to try to get the distance for each point, for each primitive to the points from the second input, and based on the distance I'm going to define this t value. Okay, so first thing first, I'm going to get all the points from the second input. Alright, then get all the point position out of the second input, attractor point position. Like that. Then going to calculate the distance between the current primitive center, the polygon center, to this attribute, attractor position. Which is distance between the at P, which is the center of the primitive, to the attractor position. Okay, and I'm going to create a threshold. If D is less than maximum searching distance. Maybe I'm going to create the parameter for that. Max search dist. If it's less than maximum search distance, then I'm going to modify t from 0 to 1 gradually. Otherwise, I'm gonna clamp it to either 0 or 1, maybe 0, or I don't know. Either way is fine. Right, so I'm going to also initialize the t. First, probably it could be 0. Then if it's less than maximum distance, then since I have many points, I'm going to get the smallest distance out of all the points. Okay, so minimum distance starting with really high value. Well, it's not really smart, but this will do. And if the distance is smaller than the min distance, then set the minimum distance to d. Right. All right, then as a result you get a shortest distance from the primitive point position to the attractor point. If it's more than maximum search distance, then the minimum distance is kept as this. So in those cases, maybe I can just say like that, because it will never go beyond this. All right, so after that, I could create a t value here by remapping the minimum distance, which is in between 0 to max search distance. And if it's equal to 0, maybe I can open up fully, or 0.5. I don't know. Then if it's maximum distance, I could make it 0 and see what happens. And does it do anything? Nope, it's not really changing. That is because I didn't set the maximum distance again. And I should remove this t parameter, which is a bit confusing to have. Okay, so the maximum distance, search distance, which this is going to be the sonar distance for each point. I don't know what's the size of this sphere. 1, the diameter is equal to 1, so maybe 0.1. Maybe a bit too small. 2.5, something like that. And okay, I do have some problem with this. It's not really connecting to each other. That's, maybe I need to fix that. But for now, based on the point, okay, I think I want to make the point moves a bit faster. All right. So overall, I think it's working. Maybe I can increase the radius a little bit. It's a bit hard to see. Maybe I can still increase the speed. It is going fast. Some of the point is going fast. Maybe I can increase the point number to 10. Okay, and probably I could also increase the this ratio to, I don't know, 1. All right. Now what I need to do is how I could connect these points together, because I'm currently rotating per primitive, which is a bit problematic. So I need to do this per points, I think, in terms of the searching points, right? Right, or per edges. Yeah, per edge might make sense. Right. So per edge means I can go into here and use these informations, maybe the middle position of this one and this one, which you will get the middle point position of the edges, and based on those point position to recalculate the t, which is doing here, maybe I can make these all connected. So shall we do that? Let's bring these to somewhere in here. Then I'm gonna create the mid position as pos as epos multiplied by half point position. Right, then use this mid position instead of the primitive position, like that. All right. now I have t, I have new t. Now I also have to change this t based on the group. So bring this. Now for this one I can do this inside a loop because I'm recreating t inside the loop all the time, so should be no problem. Let's see what happens. Now all the points being connected like that. Cool. Works fine. All right, I think it's working. Now let's give this a material. Again, go back to the material tab. Change this to a gold matte cap. There you go. A simple tweak makes this spinning customly based on the point position from the solver. All right. Hope it makes sense. And shall we change this to other geometry to see what happens, like pig head. It's more like a parasite. Okay, interesting. Donut. Cool. Square pig head. Rubber toy. All right. Okie dokie. Okay, overall, I think I am satisfied. Thanks for all the comments. Looks a bit like a 3D scan with the pig head. Yeah, I agree. Okay, well, I am going to organize these a little bit by promoting all the parameters that I set to one node so that it will be easier to modify all the parameters. And after that, I guess I am going to finish this live. Okay, so as always, I'm going to create a node with a controller name. I'm just going to drag and drop all the parameters that I could control to change the shape, something like shape switch. Or seed, random seed for the starting point. Okay. And these are automatic. Right. This one, this could be another parameter to switch between different, what was it? Different animation, different surface deformation. Was it? Yeah. Okay, other than that, I have this switch again. This is to rotate uniformly or using a attractor. So this could be rotation type. From 0 to 1. Other than that, there are small parameters like this one. Especially this, for this one, I have a bunch of parameters that I could control. Maybe I can split the parameter using some separator, and then attractor point number. This is, what was it? S stands for the noise seed. Then this, am I using this frame? Yeah, frame is the seed, the scale, kind of a scale. Cool noise scale. Which doesn't have to be integer, but I'll just make it as integer. All right, and this one, max search distance. We have also a moving speed. That's a lot of parameters. All right. And for this one, not much. All right. And for each of these, this one doesn't have any. This one, what was this about? Okay, simple noise animation. Maybe I could use another separator here. Not really clear what it's mean, but just listing up all the parameters that I created, and then these tangent field, maybe I could bring all these. Turn noise scale. This is still a surface deformation. Turn noise scale. Wait. Okay. And frame. Turn noise period, since we are using periodic noise, and that's pretty much it, I think. Okay, that's a lot of parameters and not so clear for some of it, but that'll do. If I change this to rotation type to 0, it's not really changing anything. That is because I have to turn this on as a final. All right. If I change this to 1, okay, deformation. Now this becomes pretty interesting, combining the vector field together with some surface deformation, making the shape randomish. Alright. Cool. That's pretty much it. Oh wow, Eric, thank you again, for the super chat. Wow, that's really something. Thank you very much. Thank you very much for attending the live for today, as always. I think I would like to finish the live here. I am going to upload the file that I have just created to a GitHub, as always. And wait a minute. Wait. Okay, I want this one to be 0. Yeah. So as always, I'm going to upload the files to the GitHub, and what was I trying to say? And you can download the file from the video description page of this YouTube. Also, I'm going to upload the files to the Patreon of my page as well. If you could support me on that, that would also be great. But it's all free to watch. So that's pretty much it. I think I might want to connect this one to all these as a final setup, because I want all the setup to be, oops, what's happening here? Okay, maybe I need to fuse it after I did this. Or maybe for this one, no, I guess it's fine using this. I think I need to fuse this. There you go. Because I wanted to connect the same color, save enabling color for every like step or every setup. Right, so looks good. So where was I? I'm going to upload the files, and I'm going to also keep the files, keep the archive to the YouTube so you can watch it later. Oh, and Willis VFX, thank you very much for the, again, the super chat. So nice. Thank you. Thank you very much. Okay. So that's it. Thank you very much, and hopefully I'll see you sometime next week again with some different topic. And thank you everybody for all the feedback, all the comments, all the super chat. I really appreciate it. Thank you. Good night. And see you next week.